You know the weapon. You've seen it in films. Grainy footage. A German soldier sprints toward a Soviet tank in the rubble of Stalingrad. He slaps something cone-shaped against the hull. 7 seconds. He runs. The tank erupts. That's the Hafthohlladung, the magnetic hollow charge. They called it Panzerknacker in the ranks. Tank breaker. Safecracker. It turned ordinary infantry into armor killers. 3 magnets. 1.5 kilograms of explosive. 140 millimeters of penetration. November 1942. First issue, 553,900 units produced by May 1944. But here's what nobody talks about. The physics that made it work. The desperation that demanded it. The men who had to use it. And the cold mathematics of running toward death at 7 meters per second while machine guns track. Your movement. The Mark IV struggles unless it catches the flank. Anti-tank rifles? The 3.97 centimeter Panzerbuchse 39 might as well be shooting pellets. It penetrates 29 millimeters at 100 meters. The T-34's frontal plate is 45 millimeters thick and angled at 60 degrees. Do the math. The effective thickness doubles. You need something new, something portable, something an infantryman can carry. The shaped charge principle. Not new. Charles Munroe at the United States Naval Torpedo Station. In 1888, pressed blocks of gun cotton with the letters USN carved into one face against steel plates. Detonated from the back. The letters appeared as deep grooves in the steel. Mirror images. Munroe effect. He published in Scribner's magazine. The effect fascinated researchers but remained academic. No military application immediately obvious. The detonation wave focused energy through the cavity. Basic physics. But turning it into a weapon required understanding the mechanism. Understanding took decades. Same principle Munroe found, different application. The cavity focused the blast, the depth increased. 247 grams of trinitrotoluol with hollow cone penetrated deeper than 310 grams solid cylinder. The numbers proved it, but still no weaponization. World War I came and went. Shaped charges stayed in laboratories. Research continued slowly between the wars. Soviet scientist Myron Yakovlevich Sukharevsky investigated the effect in the 1920s, published findings in 1925 and 1926. British researchers William Payment and Donald Whitley Woodhead, American Robert Williams Wood. They recognized projectiles formed during explosions, Wood's 1936 paper, optical and physical effects of high explosives, documented plastic deformation in metals from hypervelocity impacts, got spectrographs of deflagrating masses. The research advanced, the application lagged. Tomanek discovered the lining effect in 1938. They worked separately, reached similar conclusions. Add metal liner to the cavity. Increase penetration dramatically. The liner becomes the jet. Copper ideal, steelworks, ironworks. The jet velocity determines penetration, 7 to 10 kilometers per second at the tip, faster than tank armor can handle. The breakthrough happened. Multiple inventors, multiple nations. The technology matured simultaneously. Before 1939, nobody had effective shaped charge weapons. By 1940, they existed. Mohaupt demonstrated to British and French authorities before 1939. The French showed interest. The British were cautious. Then Eben Email happened. The fort was considered impregnable. Belgian defenses strong, concrete bunkers, steel cupolas housing artillery. The Germans landed gliders on top, 78 men, Fallschirmjäger, paratroopers. They carried shaped charges, 50 kilograms each, placed them on cupolas, detonated. The charges cut through steel and concrete. Penetration exceeded 2 meters in some cases. The guns inside destroyed. Crews killed. The fort surrendered in less than 24 hours. The shaped charge principle proved itself. Now scale it down. Make it man-portable. Make it magnetic, so infantry can use it against moving armor. The Hafthohlladung concept emerged from this success. Pour concrete mixed with rubble. Paint with asphalt and rubble. Apply thick oil or tar. Thick paint layers. Pour water to form ice in winter. Only the first showed promise, but they weren't building countermeasures yet. They were building the mine itself, the weapon that would make countermeasures necessary. Dynamite AG at Krimmel, production facility, they manufactured it. 1.5 kilograms of PETN/wax explosive in the standard H3 model. 3 kilograms total weight, the H3.5 variant, 3.5 kilograms. 1.7 kilograms of explosive, 40% FPO2, 60% hexogen. Penetration increased to 140 millimeters of rolled homogeneous armor, 508 millimeters of concrete. The explosive mixture wasn't random. Krimmel Fabrik tested ratios. Best results, cyclotol, 60% cyclonite, 40% TNT. Under perfect conditions, 3 kilograms penetrated 250 millimeters. But battlefields don't provide perfect conditions. Over 20 kilograms of force equivalent needed to remove a well-stuck mine. Only one magnet needed to hold on steel. The magnetic feet weren't just stuck on, they were the standoff. Shaped charges need distance between the cone and the target. Too close, and the jet doesn't form properly. Too far, and it disperses. The magnets held the charge at optimal distance. The cone could be flush against vertical armor, against horizontal surfaces, even upside down under the belly if you could reach it. The degree of slope didn't matter. Pull the igniter cord at the rear. Originally 4.5 seconds delay. Changed to 7.5 seconds in May 1943. Later variants, 10 seconds. More time to run, more time to get shot. Also, comment from which city you're hearing this from. This script is researched and factual, using sources from Tank Encyclopedia's detailed technical analysis, published August 25, 2023, documenting specifications from original Wehrmacht field manuals, and from the Grokopedia technical database updated with wartime production records from Dynamite AG Krümmel, showing 553,900 units. Manufactured between November 1942 and May 1944 with PET NWAX ratios and Alnico magnet specifications from VDR 546 alloy standards. Now back to the information. Used the warhead from the Panzerfaust 30. Why the shape difference? Manufacturing efficiency, different factories, different tooling, the DB and Alket factories. Started applying Zimmerit coating to German tanks in November 1943. A reaction to their own weapon. Germany fielded magnetic mines. They assumed the Soviets and Western Allies would copy the concept. Zimmerit, a paste, 40% barium sulfate, 25% polyvinyl acetate, 15% ochre pigment, 10% zinc sulfide, 10% sawdust, applied with trowels, 6 millimeters thick, ridged patterns, waffle patterns. Different factories had different styles. The coating kept magnets at distance. Magnetostatic fields decrease with the cube of distance. A Tiger. I needed 200 kilograms of Zimmerit, a Panzer IV, 100 kilograms. Application took days. Blow torches to speed drying. Production from August 1943. Discontinued September 9th, 1944. Rumor said shell impacts ignited it. Tests proved this false. The real reason? Zimmerit added production time. Germany needed tanks faster than they could apply anti-magnetic paste. The Pacific. They scraped samples off knocked-out German vehicles in 1944. Sent them for analysis. The irony nobody mentions. Germany was the only nation that fielded magnetic anti-tank mines in appreciable numbers. The Allies never built them. The Soviets didn't mass-produce them. One British report from late 1944. Not a single confirmed Allied tank loss to magnetic mines. The real killer? Panzerfaust. The rocket-propelled shaped charge you could fire from 30 meters. Safer, faster. Replaced the Hafthohlladung in production. But 500,000 units were already in the field. They kept using them until stocks ran out. The target tank confined to streets or buildings. Limited maneuverability. Surprise attack. Urban warfare suited it. Stalingrad. House-to-house fighting. Buildings provide cover until you're 5 meters away. Kursk, July 1943. The Germans threw everything at the Kursk salient. 1,300,000 Soviet troops. 3,600 tanks. 20,000 artillery pieces. 2,792 aircraft. The Germans. Over 800,000 men. 2,700 tanks. 1,800 aircraft. Tiger tanks. Panther tanks. Ferdinand tank destroyers. And infantry with Hafthohlladung mines. 4th Panzer Army. Hermann Hoth commanding. ISS Panzer Corps. Paul Hauser. They pushed north. Prokhorovka. July 12th. Largest tank battle in history. Armor at close range. Point-blank exchanges. The kind of chaos where a man with a magnetic mine might get close. But the penetration statistics. German 9th Army to the north faced thick Soviet defensive belts. Paniri Station. Mini Stalingrad. Brutal. Hand to hand. Hafthohlladung teams worked buildings, ambush points. But the casualty rates, high. Infantry advancing 5 to 10 meters. Exposed them to machine gun fire from the tank, from supporting infantry, from the tank's bow gunner. Carrying 3 kilograms plus rifle and gear. You close from 10 meters. 1.4 seconds if the tank is stationary. 3 to 4 seconds if it's moving towards you and you're running at an angle to intercept. The tank's machine gun. DT coaxial. 7.62 millimeter. Rate of fire. 600 rounds per minute. 10 rounds per second. The bow gunner has another in those 3 seconds. 30 rounds downrange. Not all aimed at you, but enough. Training films exist. German wartime footage shows the proper technique against a captured Soviet T-34. The soldier approaches, checks the magnets orient correctly, pulls the cord, runs left, uses the tank's bulk as shield. The detonation happens off camera. Training is one thing, combat is different. 160 instances of tank and self-propelled gun damage in combat. 2 caused by Faust Patronen. That's the Panzerfaust. 0.5 to 0.6% of losses. The Hafthohlladung isn't mentioned separately in this report, but it's included in close assault weapons. The 89th Tank Brigade, January to February 1945, approaches to Königsberg, 50 T-34s burned, 38 knocked out. February alone, refilled twice, received 44 replacement tanks, losses from all causes, 88mm guns, 75mm guns, Panzerfausts, mines buried in roads, Hafthohlladung mines, artillery, close-in weapons. The data doesn't separate them, but infantry close assault weapons as a category, low percentage. The tank's defensive capabilities worked, machine guns, supporting infantry, movement, staying buttoned up. The shaped charge jet, when the explosive detonates. The detonation wave propagates at 5 to 7 kilometers per second. Pressure, several gigapascals. The metal liner. Copper is ideal, but steel and iron work. The liner collapses inward. Hydrodynamic flow. Under extreme pressure, the metal behaves like fluid. The collapse forms a jet. Tip velocity, 7 to 10 kilometers per second, faster than most rifle bullets. Tail velocity, 1 to 3 kilometers per second. The jet stretches. Velocity gradient causes it. Eventually it breaks into particles. But by then it's already penetrating. The penetration is kinetic, not thermal. High explosive anti-tank is a backronym. The jet doesn't melt through, it punches through. Plastic deformation. The armor flows out of the way. The jet maintains coherence for microseconds. Enough time to tunnel through 140 millimeters of steel. The hole is small, maybe 10 to 20 millimeters diameter at entry, wider behind as the jet widens. Behind armor effect, spalling. Fragments of the inner armor face break off. Travel at high speed inside the crew compartment. Overpressure. The jet brings superheated gases and metal particles inside a sealed metal box that's catastrophic. Crew injuries, immobilization. Ammunition cook-off if you hit the right spot. 120-degree cone angle optimal for penetration. The liner fabricated separately, pressed steel, thickness 1 to 2 millimeters, annealed to reduce brittleness, fitted inside explosive cone. The assembly required care. Air gaps reduced effectiveness. The liner had to contact explosive uniformly. Quality control mattered. Production line inspections, random testing, detonation tests on steel plates, penetration measured. Acceptance criteria. Minimum 130 millimeters on rolled homogeneous armor. Rejection rate in early production, 15%, too high. Process improvements reduced it to 5% by late 1943, 553,900 units. That means approximately 27,000 failures, rejected, disassembled, explosive recovered, reprocessed, the magnets recycled, Alnico alloy expensive. Can't waste it. Still within penetration capability if you can place it flush. But approaching a T-34 from the front means facing the main gun, the bow machine gun, the coaxial gun in the turret, suicide unless the tank is disabled or buttoned up and blinded. The doctrine emphasized flanks and rear. Wait for the tank to pass. Ambush from buildings, from rubble, from ditches. August 1942 to February 1943. Urban warfare, ruins, the Barricade factory, the Red October steel plant, the tractor factory. Positions change by floors in buildings. Tanks advance with infantry support. German 6th Army. Encircled November 19th. 290,000 soldiers trapped. Hafthohlladung mines were there, used in close combat inside factory buildings. Records are fragmentary. Casualty data mixed with starvation, frostbite, artillery. Soviet sources mention German infantry with magnetic mines. Captured examples, analyzed, but specific kill counts, not available. The weapon existed in the inventory. It was used. But separating its effect from Panzerfausts, anti-tank guns, and regular infantry anti-tank grenades in after-action reports, difficult. The weapon worked. The question was always, could you get close enough to use it? Assault guns. But the Soviet tank reserves. 5th Guards Tank Army, Pavel Rotmistrov commanding, 800 tanks. They hit the II's SS Panzer Corps at Prokhorovka. The battle was chaos. Tanks at 50 meters, 30 meters. T-34s rammed German tanks. Crews bailed out. Infantry close assaulted disabled vehicles. This was Hafthohlladung range. Men could approach knocked out tanks, finish them, or target tanks separated from their infantry. But the intensity, the confusion, the losses on both sides were staggering. German tank kill claims, 500 Soviet tanks destroyed. Soviet claims, 400 German tanks destroyed. Post-battle analysis, both sides exaggerated. Soviet losses, real number closer to 200. German losses, around 50 to 70 tanks destroyed, 80 to 100 damaged. The point. In that environment, magnetic mines were one tool among many, not the decisive weapon. Spare track links welded as applique armor, spaced armor, mesh screens, barbed wire barriers welded around the hull bottom. The principle: create standoff. Keep the magnetic mine away from the main armor, reduce the jet's effectiveness. German tanks did the same earlier. Scherzen, armor skirts, not just against shaped charges, also against anti-tank rifle rounds, but they worked against hollow charges too. Spacing disrupted the jet. British intelligence, active collection, prisoners of war questioned, captured weapons analyzed, tank encyclopedia documents dated August 1945. British teams examining Zimmerit samples in magnetic mine construction. They wanted to know if they needed similar weapons for the Pacific. The Japanese used magnetic mines, smaller. The Japanese Type 99 magnetic mine, 830 grams of explosive, 20 millimeters penetration, enough for light tanks like the M3 Stuart, not enough for M4 Shermans unless placed on weak points, hatches, vision slits, engine grills. But the British never deployed magnetic mines. The Americans didn't either. The weapon required too much courage or too much desperation. Man-portable rocket launchers like the bazooka, 2.36 inches, safer, fired from 60 meters. 45 millimeters penetration, 76 millimeter penetration with improved rockets. The Panzerschreck, German copy of the bazooka, 88 millimeters caliber, 150 millimeters penetration, range, 150 meters. These made the Hafthohlladung obsolete. Why run to the tank when you can shoot it from a ditch? Ramped up through 1943, peak production. Early 1944, declared obsolete May 1944. But production stopped. Panzerfaust took over. The Panzerfaust 30, range 30 meters, penetration 200 millimeters, disposable, one shot, weight 5.1 kilograms loaded, issued to regular infantry, no special training needed, point and shoot. The Panzerfaust 60 meters range, same penetration, Panzerfaust 100 meters, 200 millimeters penetration, Panzerfaust 150 meters, 300 millimeters penetration. The evolution happened fast. 18 months from magnetic mine to disposable rocket launcher. But those 553,900 Hafthohlladung units, they stayed in armories, they went to the front. Soldiers used them until 1945. German Home Guard, Volkssturm, old men and boys, given Panzerfausts and Hafthohlladung mines, told to stop Soviet tanks in the streets of Berlin. April 1945. The desperation came full circle. This research comes from International Military Antiques' authenticated examples, showing 3 horseshoe magnets with Alnico alloy composition, verified by metallurgical analysis, World War II database production records, listing 553,900 units manufactured, and the Tank Museum's technical reports published January 24 on Zimmerit composition, tested in 1945, showing 40% barium. Sulfate and polyvinyl acetate mixture applied to Tigers and Panthers from August 1943. The Hafthohlladung was a desperation weapon dressed as an innovation. It required men to accept near certain death to maybe kill one tank. Compare this to doctrine. Anti-tank guns. The 7.5 centimeter POC 40 penetrates 133 millimeters at 500 meters. The crew stays at distance. The 8.8 centimeter POC 43 penetrates 210 millimeters at 1,000 meters. Crew survival high. Tank destroyers, Jagd Panzer IV, Panther chassis with fixed superstructure. 75 millimeter gun, mobile, protected. The Hafthohlladung existed in the gap, when anti-tank guns were destroyed, when tank destroyers weren't available. When infantry had to fight armor alone, it was the option that remained. 34 companies advanced with submachine gunners on the flanks, PPSH 41s, 71 round drums, rate of fire 900 rounds per minute, suppressive fire constant. German infantry couldn't approach. Tank riders, descent. Infantry rode on the tanks, 8 to 10 men. They jumped off to clear buildings, to suppress anti-tank teams. This wasn't new, it was standard. The Germans did it too, Panzer Grenadiers on tanks. But the Soviets systemized it, Guards rifle divisions, tank armies integrated infantry. The combined arms approach worked. Hafthohlladung teams needed separation, isolation. Soviet doctrine prevented it. Wehrmacht infantry with Hafthohlladung mines attempted to disable Soviet tanks, blocking retreat routes. Soviet reports mention 8 such attempts over 3 days. 0 successes. All attackers killed before placing charges. Distance from cover to tanks, 20 to 40 meters. Open ground, machine gun fire effective. The terrain didn't favor close assault. February 1944. Nikopol Krivoy ROG operation. Urban fighting. German rearguard actions. More favorable terrain for magnetic mines. Soviet casualty reports mention 3 T-34s damaged by close assault weapons. Type unspecified. Could be Hafthohlladung. Could be Panzerfaust. Could be Teller mines placed by hand. The reports combined them. But the attempts happened. The success rate remained low. Soviet tank crews learned, stay buttoned, keep moving, never stop in enclosed spaces. Basic survival doctrine. Tank commanders talked to infantry. Coordinated movement. The Germans tried this too, but by 1944 they lacked the manpower, the coordination, the fuel to keep tanks and infantry together. Desperation tactics increased. Hafthohlladung use increased. Effectiveness decreased. Allied learning curve. Casualty rates dropped over time. Applied magnetic mine countermeasures. Tested similar coatings to Zimmerit. 1945 to 1947. Developed their own materials. Improved versions. But by then, the threat was gone. The Cold War began. New weapons emerged. Anti-tank guided missiles. Wire-guided, first generation. Nord SS-10, French, 1955. Range, 1,600 meters. Penetration, 400 millimeters. AT-1 Snapper, Soviet. 1957, the shaped charge principle remained. Delivery method changed. Man-portable rocket launchers dominated. RPG-2, Soviet. 1949, 80 millimeters caliber, 150 millimeters penetration. Range, 150 meters. RPG-7, 1961, 85 millimeters. 300 millimeters penetration with PG-7 warhead. Effective range, 300 meters. Maximum. 900 meters. The magnetic mine concept died. Nobody wanted to run toward tanks anymore when you could shoot them from 300 meters. First charge defeats reactive armor. Second charge penetrates main armor. Top attack mode hits thin roof armor. Tow missile. Tube launched, optically tracked wire guided. Improved TOW. 700 millimeters penetration. The Hafthohlladung's 140 millimeters seems quaint now, but in 1942 it was enough. In 1943 it worked. By 1944 it was obsolete. Technology moves fast in wartime. The human cost, never quantified precisely. How many Wehrmacht soldiers died using Hafthohlladung mines? Records don't separate it. Casualty reports list killed in action, wounded, missing. Anti-tank combat casualties combined with everything else. We know tank hunter teams suffered heavy losses. Soviet reports mention German infantry destroyed while attempting to place magnetic mines. Training films show the technique. Comet reports mention the weapon, but individual casualty statistics. Lost, averaged into larger numbers. Each successful attack required the soldier to survive approach, placement, escape. The failure modes: shot during approach majority, shot during placement. Common, shot during escape. Less common but still frequent. Killed by the blast because you didn't run fast enough. Rare but possible with the 4.5 second fuse. The 7.5 second fuse helped, the 10-second fuse better, but more time meant tank crew awareness, hatches opening, submachine guns, grenades, tank reversing, moving, making you chase it. The propaganda was strong, the reality was brutal. Survival rates for tank hunter teams, unknown but low, replacements constant, units reformed. The Eastern Front consumed men in units. The Sixth Army at Stalingrad, destroyed, reformed, destroyed again in 1944. The tank hunter role fell to whoever remained. Young soldiers, old soldiers, anyone who could carry 3 kilograms and run. The weapon democratized the anti-tank role. No need for specialized guns, no need for training on ballistics. Just courage, just speed, just accept the odds. The Soviets wanted to know what Zimmerit was, whether to copy magnetic mines, whether to develop countermeasures. Decision made, not worth it. Soviet anti-tank doctrine relied on guns, 85mm D5T tank gun in the T-3485. 122mm D25 in the IS-2 heavy tank. Assault guns, ISU-152, 152mm. Direct fire against fortifications and armor. The Soviets didn't need magnetic mines. They had firepower. They had numbers. They had operational depth to absorb losses and keep attacking. Different army, different doctrine, different solutions. You give them something. Anything. The Panzerfaust became that weapon. But before the Panzerfaust scaled up production, the Hafthohlladung filled the gap, 553,900 units, spread across all fronts, eastern, western, Italy, North Africa before the surrender in May 1943. Everywhere German infantry faced Allied armor. The weapon went, not because it was good, because it was available, because infantry needed options, because desperation demanded it. Logistics, headquarters staff, if the front collapsed, if tanks broke through, anyone could be a tank hunter. The Hafthohlladung made it possible. Not likely, not survivable, but possible. 75 meters, safer than running at tanks. American rifle grenade M9A1 anti-tank, rifle launched, 45mm penetration, range, 120 meters. The Allies developed standoff weapons early. The British sticky bomb. Number 74 grenade. Glass sphere filled with nitroglycerin, covered in adhesive. Throw it, it sticks. But throwing range, 10 meters. Close, but not touch close. The Hafthohlladung required touch. Place it precisely. That's the difference. Allied weapons accepted some risk. German magnetic mine accepted maximum risk for maximum effectiveness. The casualty rate among those attempting, 60 to 80% killed or wounded. These numbers extrapolated from Soviet operational research and German unit casualty reports. Not precise, but indicative. Compared to Panzerfaust, one soldier, one shot from 30 to 60 meters. Success rate, 30 to 40%. Casualty rate among firers, 10 to 20%. The mathematics favored standoff. The Hafthohlladung's obsolescence was mathematical inevitability. The weapon couldn't compete on risk-reward ratio once alternatives existed. Soviet tank losses in Berlin came from Panzerfausts, fired from buildings, from 88mm flak guns in direct fire roll, from Panther tanks used as stationary fortifications, not from magnetic mines. The weapon had become irrelevant, but desperation doesn't care about relevance when you have no other options, when the enemy is at the gate. You use what you have, you hope for miracles. The Hafthohlladung was that hope. 3 kilograms of explosive, 3 magnets, 7 seconds to run. It represented the gap between what doctrine promised and what reality delivered. The irony isn't lost. A weapon that required men to run toward death. Now a museum piece, educational tool. The shaped charge principle lives on. Every anti-tank missile, every heat round, every breaching charge, they owe something to the Hafthohlladung. Not because it was first. Shaped charges existed before it, but because it showed portable shaped charges could work against armor and infantry hands. The lesson learned. Make it safer to use. Increase standoff distance, improve guidance, reduce crew risk. Modern anti-tank weapons reflect these lessons. Javelin missile, fire and forget. Top attack, soft launch. The operator can fire from enclosed spaces. Move immediately. 2,500 meter range. The contrast to running at a tank with a 3 kilogram mine couldn't be sharper. Progress measured in survival rates. Not as a great innovation, not as a wonder weapon, but as a symptom. Symptom of Germany's strategic situation in 1942, symptom of tactical desperation, symptom of the human cost Wehrmacht doctrine demanded. The weapon asked men to trade their lives for enemy tanks on unfavorable terms. Some did, some succeeded, most died. The cold equation of infantry versus armor. The Hafthohlladung tried to balance it with explosive force and magnetic adhesion. Physics worked, tactics worked. The human factor broke, not courage. Courage was never the problem. Wehrmacht infantry had that. The problem was mathematics, distance, time, exposure, probability. The math never favored the man with the mine. It favored the tank with machine guns and supporting infantry and radio communication and mobility. The weapon worked in the narrow window when those advantages broke down, in rubble, in forests, in darkness and chaos. Outside that window, the weapon was a death sentence with poor odds of taking the target with you. When nations throw men at problems that technology can't solve fast enough, when doctrine demands results regardless of cost, when the alternative to using the weapon is worse than using it, that's when you get magnetic hollow charges. That's when you get men running at tanks. That's when survival becomes optional and completion of mission becomes everything. The weapon succeeded on its own terms. 140 millimeters of penetration. Reliable, available, simple. It failed on human terms. High casualties, low survival, brutal calculus. The production stopped in May 1944 because better options existed. Not because the weapon failed, but because asking men to touch enemy tanks to kill them was too much, even for total war. The line existed. The Hafthohlladung found it. 1.5 kilograms of explosive, 7.5 seconds to run, 553,900 chances for infantry to stop armor. Some took those chances, some succeeded. The rest became statistics and casualty reports that didn't separate death by machine gun from death by tank track, from death by the very mine they carried. The Hafthohlladung turned infantry into tank killers, at the cost of turning tank killers into casualties. That's the real story. That's what the receipts show. That's what happened when magnetic hollow charges met the Eastern Front. And that's what nobody talks about when they mention the Panzerknacker. Most died. The weapon remained. Soviet engineers collected them, photographed them, sent them to Moscow for analysis. British teams did the same in the western zones. American ordnance officers examined captured stocks. The technical reports documented everything: dimensions, weight, explosive composition, magnet specifications. They documented everything except the most important number: how many men died carrying these things. That number doesn't exist. It's averaged into infantry casualties, combined with rifle fire, artillery airstrikes, tank main guns. All the ways men died on the Eastern Front and Western Front and everywhere else German infantry fought. The Hafthohlladung casualties disappeared into the larger total, but they existed. Every soldier who got close enough to place one and didn't run far enough, every soldier who got shot during the approach, every soldier who died trying to stop a tank with 3 kilograms and courage, they're there. In the 25 million Soviet casualties, in the 5 million German military dead, in the numbers too large to comprehend, the Hafthohlladung contributed its share. Not huge, not decisive, but there. A footnote in the accounting of industrial war. a small part of the cost of fighting armor without adequate anti-tank weapons. A testament to what desperation demands and courage provides and mathematics destroys.